Hey, we have on the board another integral from the MIT Integration Bee 2020. This was problem number 11. We have an integral from 1 to square root of 2 over 2 arcsine of x over x cubed dx. Okay, so we have an arcsine in the expression. So what I want to do is use integration by parts because we don't really have a good way to integrate that. So let's use the DI method or tabular integration. So we'll create two columns, one to differentiate, one to integrate. We're going to differentiate our arcsine because, like I said before, it's hard to integrate that. And we'll write our x cubed as x to the minus third because it's in the denominator there to integrate. Then the derivative of arcsine is going to be 1 over the square root of 1 minus x squared. And our integral of this thing is going to be x to the minus 2. Then we'll put our minus 2 in the denominator. So then we're going to have part of our solution right here on this diagonal. But then what I want to look at is, I think we can integrate this right here. It's just going to be a little tricky. So let's break that out separately. Okay, so what I've done is I've multiplied this minus sign times minus sign to just cancel out and have a plus. And I took this 2 and brought it out front of the integral. So we have this 1/2 here. And now what I'd like to do here is I want to do some kind of u substitution, but it's not quite working. What I want to try is, let's see if we can factor out from here so that we can do a u sub. What I'll do is factor out an x squared here. So let's go down here and we're going to have x to the negative 2. When we factor out an x squared, we're just going to have a x on the outside of the integral. And then we're going to have x to the minus 2 minus 1 dx. But then we can just combine this with what's in the numerator, and we're going to have 1/2 x to the minus 3, x to the minus 2 minus 1 dx. And now I think we're in good shape for our u substitution. So let's make this our u. So u is x to the minus 2 minus 1. du is going to be minus 2x to the minus 3. So that's going to work out nice. dx. And what I'm going to do is I'm just going to add a minus 2 right here in order to make this work a little nicer. And we'll just have to bring a minus 1/2 out here. Okay, so now I've multiplied out minus 1/2 and 1/2, and we got our minus 1/4 out front. I made the substitution. We're just going to have du over the square root of u, noticing that our numerator is du and this is u right here. So let's just write this in the numerator so it's a little easier to see the integration. So this is going to be the integral of u to the minus 1/2 du. And so now we're ready to integrate. And we're going to have minus 1/4, integrating u to the minus 1/2 with the power rule. We're going to have 1/2. Then the reciprocal of that is just going to be 2. So then for this piece of the integral, we're going to have minus 1/2 square root of u, which is x to the minus 2 minus 1. Okay, and so that's this piece. So now we just need to put all this back together because back to our original, we have this piece of the answer that we need to include, and we also have to put back our limits of integration. So our sine inverse here of 1 is going to be at pi over 2. We have our minus sign, and this is going to be over 2x squared is just going to be 2 minus 1/2. This piece is going to be 0. When we plug 1 in here, 1 minus 1 is 0. So let's just remove that. Then let's evaluate our square root of 2 over 2. Sine inverse square root of 2 over 2, this is going to be pi over 4. Just evaluating that. And then 2 squared, and then we're going to have, here, let's just write it like this, square root of 2 squared, but this is going to be 1. I think this is all going to be 1. There's going to be 2/4. Yes. So this piece is going to go away. It's just going to be 1. And then doing this part, get our 1/2. We put square root of 2 over 2 in here, but we flip it. When we evaluate this piece, we're just going to have, this is going to be like square root of 2 squared is 2 minus 1 is 1. So we're just going to have our minus 1/2 here. Then just putting this all together, here we have a minus pi over 4. And then here, evaluating a negative pi over 4 is going to be a plus pi over 4. So you can see this is going to cancel to 0. And we're just left with distribute our minus sign here, and we're going to have just 1/2 for the solution. That was MIT Integration Bee 2020, problem number 11. Thanks for watching. Please like and subscribe. Have a great day.